Hi students, today we're going to do 12.3. Newton's third law. For every action, there's an equal and opposite reaction. So these are some things where you actually might see the equal and opposite reaction. A hammer and a nail. When you strike a nail with a hammer, the hammer puts an action on the nail, and the nail actually does a reaction on the hammer, which is why your hammer might swing back a little bit. Walking on the ground, the reason why you're able to spring back forward is because when you push on the earth is also giving an equal and opposite reaction to you, which makes you walk. Swimming is the same type of idea, and hitting a ball with a bat, sometimes you'll even see the bat swing backwards a little bit because of the reaction force of the ball on the bat. Action versus reaction. Forces always act in pairs. Another example is a bush pushes down on the table is an action force, and the table pushing up on the book is actually the reaction force. That's one is a little bit harder to see, but the forces are equal in size and they're opposite in direction. So here's some pictures of it. Here in this picture, this shows you the book pushing up, or the table pushing up on the book is the reaction force, and the book pushing down on the table is the action force. The book is pushing down with the weight, and then the table is pushing back up with that with the same force. You might have seen this with guns. Guns, when you fire a gun, the gun pushes on the bullet, that has an action force on the bullet, and then the bullet has a reaction force on the gun, which is why the bullet is able to go forward and why the gun has a kickback because of the reaction force from the bullet. And that's how rockets work as well. It's because of the action and reaction forces between the rocket and the rocket fuel being expelled. Momentum is defined as the mass times the velocity of an object. It is measured in kilograms meters per second. It is not kilograms meters per second squared like what Newton is equal to. As mass goes up, momentum goes up. As velocity goes up, momentum goes up. Calculating momentum. Momentum is equal to mass times velocity. This P is your momentum. And then we've got the mass and the velocity. So your P is in kilograms meters per second. The mass is in kilograms and the velocity is in meters per second. You do need to know how to rearrange the equation. So you should also know that mass is equal to P over V and velocity is equal to P over M. So what is the velocity of an object that is 8 kilograms? Object that has a momentum of 123 kilograms meters per second. First, you want to write the equation. So velocity, because we're looking for velocity, is equal to momentum over the mass. And so we're going to put the 123 kilograms meters per second on top and divide by 8 kilograms. So we're going to cross out the kilograms because you'll be left in meters per second. And this equals 15.375 meters per second. The momentum, what is the momentum? You would take P equals mv, and then you'd want to multiply your 23 kilograms times your 16 meters per second. If you take 23 times 16, we get 368 kilograms meters per second. Law of conservation of momentum. If no net force acts on a system, the total momentum of the system does not change. In a closed system, the loss of momentum by one object equals the gain in momentum of another object, hence momentum is conserved. This equation will be given to you on the test, however, you will never use it that way. It's basically saying the momentum of one object is equal to the momentum of the same object because law of conservation of momentum. So you will always need to solve for either M1 or V1. So to get rid of the V1, you want to divide by V1 on both sides. So you would get M1 equals M2 V2 over V1. And then if you wanted to solve for V1, you'd get M2 V2 over M1. So a 75 kilogram rocket expels 25 kilograms of gas at 65 meters per second. How fast will the rocket go? So we know we have to use the law of conservation of momentum equation if you have two masses and one velocity, or if you had two velocities and one mass. So in this case, we have two masses and one velocity. You will have to use the equation that we just talked about. So in this case, since we're looking how fast, you're going to be looking for V1 equals M2 times V2 over M1. Now the hardest thing to figure out is which one's the M2 and the M1. Just so whatever is your V2, so this is your V2, you need to figure out what mass that one is. So this is the 65 meters per second was your gas, so that means the mass of the gas, which is 25, is also your M2, so this has to be your M1. So we're going to have 25 kilograms times 65 meters per second over 75 kilograms. So you want to take 25 times your 65, and then you will divide by 75. And you get 21.7, and the kilograms cancel out, and you'll be left in meters per second. That's it.